Yeah, welcome back to my class today. Today we are going to look at keywords in C. Now, if you look at what I have on this board, the ANSI C initially had 32 keywords. Now, but subsequently, after several versions, other keywords has now been added, right? Now, if you look at this, I'm just dividing them into different groups, but there are still more. So like in this one now, we have data types. We have int, float, char, double. There are other ones. Then we have control flow. So we have if, else, case, switch. There are many more too. Then we have the storage, which is auto, extend, static, memory management. You can use a function, this malloc function. And then these are some of the new ones that have now been added. I told you identifiers when you are naming something, but you can't use a keyword for identifier. So you can't use any of these to name a variable or to name a function because these are predefined terms in C. Now, what actually is a keyword? It's the programmers, those that created the C language. What a keyword simply means is, for example, now I told you I'm from electronics background. So I'm going to use something. So you've seen this, right? Let me just show you something. In electronics, we have something like this, right? And then I have another one like this, and then I have another one like this, and then I have another one like this, right? So I have this here, then I have this, then I have this, then I have this, then I have this. Hope I'm right. Okay, so this is positive, this is this, and then this is this, and then this is this. Okay, so I have this going like this. Okay, now these are diode, right? These are diodes, this, and this. But this complete circuit is called rectifier, right? This is called a rectifier, this complete combination. So in electronics, the moment I say a rectifier, I have this image in my head. So the same thing happens in C. When they are creating this integer, it is a designed to allow the flow of energy. This one allows the flow of electricity, right? And this is used for conversion of electricity from alternative current to direct current. So this is where the input is coming, and this is the output. So the input is coming in here, and then we are converting that alternative current to what? To a direct current using this. So the moment I say rectifier, in your mind, you create this circuit. Exactly the same thing is happening in the C language. When you hear the keywords, for example, integer, is actually a rem. So I've been telling you. So this is a rem, this is another rem, this is another rem. Now, when I create a variable and I give it a name, which is what? An identifier, that is like a messenger that goes to carry whatever literal value, which I'm going to teach you in the next class, that is going to carry it. So what is actually happening is that when they created the C language, those that originally created it had certain keywords that they use to name the circuit design that they've created. So all you are going to do is you are going to build on that using those things. So anytime you write your code, which is an instruction that you've given, you are going to use the keyword, and the compiler is going to check if you've arranged the circuit the exact way it should be. So every time we write our program, that is what is happening. So any of these names that you are seeing is actually a name designed just like this. So energy is going to flow. So that data is actually a carrier of energy. So what the developer is doing is that the developer is a bridge. I'm going to teach you that in the next class. So these are the keywords that are used in C. And have it at the back of your mind that these keywords are pre-designed circuits like this to carry the data. So you can't use them to name an identifier. It will cause conflict. Because when you name an identifier, a compiler already knows how that keyword is designed and it knows what it's going to do. So when you are using it to name an identifier, it will give you an error. I told you that in the last class. So these are keywords, right? And we've been using them as we've been writing our code. But for me to specifically show you in this class is just to explain to you what these things are doing. You say if, you say else, you say case, you say switch. They are control flow. So meaning when the data is coming, that carrier of energy, when it is coming, it can get to a point where it will have to decide. So like this one now, you can see what is designed here. So when it is coming here, there's something that is happening at this junction. So you can equally say if. So you can see this is breaking into two. So something is happening inside this, and then it will give you an expected output. So every keyword is is a circuit designed that is going to give you an expected output. So they've done that. That is how they created the C language. So that is just basically what I want to show you in this class. So that as we go on and you start seeing me using more of these keywords, right, you will now be able to understand what they are doing in your program. That is just what I want to show you. So if I now write a program like this, if I write a program and I say, this include stdio.h, right? And then I say int main, and then I put this here, and then I say float, then I give it a name. Let's say I call it a tete, right? And then I assign a value to it, and I say 10.5, my statement. Then I say print f, right? And then here I say the value, or I just come here and I say, I want to print it out on the screen. Then I do this. So this one is going to expect percentage %f. Then I close this, comma. Then I will type a theta here. Then my statement. So I say return 0. Then here I will close my program. So this is a keyword that I've used here, just like this. So I'm telling you, this is a rem. And then I'm creating this messenger inside this rem. And then I'm assigning this value to this messenger. Then I'm calling my print function, right? Then I am giving this string literal to it. So I am saying, go to the memory location that is named etete and print out the value. So this is going to print this string literal, which is what? Etete. It's going to print it out, right? On the screen. And then it will do this, and then it will print out this value, 10.5. But 1, 2, 3, 4, 5. So it will print out this on the screen for me to see. So I just want to show you how the keyword. So you can see this is a design. This is a design. And in the next class, which is what I'm going to teach you literal, which is actually this. I'm now going to teach you and then completely explain how this circuit is working for the data to flow from wherever it is to wherever it is going to. So I just need you to follow up, because in this, what we are doing in this series now is just showing you the component parts that we use in writing our program. So when we start writing, you will already have understood why we are bringing them in to create the final solution to whatever it is that we are trying to solve. That is what I want you to see as I teach you this. So note that those keywords are actually circuit that the owners of or the creators of C language sat down to design. Now, when you are coming in, you are just adding to it or using them to navigate your way and making your energy flow. as you want it. So in the next class, I'll be teaching you literals, where I'm going to sum everything up together and completely explain the script to you for you to see. So till we see in the next class. Bye-bye.